are. And you know what? The example I want to walk you through today has to do with a cadre in the university setting. Okay. And you know what? Apart from that, I'm also going to, walk you through different ways of assigning weights. What do I say assigning weight? Assigning contrast weights. I think I show you one example of assigning contrast weight on Friday. I'm actually going to show another today. So like I said, what I have for you today is contrast in ANOVA without. Of course, we're going to have a review on contrast, then we're going to do contrast in R. Now, I want you to take a look at what I'm projecting right now. If you want to consider salaries of professors, I want to tell you we have cadre. Of course, we have what we call the tenure and the non-tenure track. Okay, I'm going to say that again. If you look at the composition, when you look at the cadre of lecturers in the university, of course, we have just like what happened in other organizations where they have cadre, we also have cadre. So some are in the non-tenure track, and while some are in the tenure track. Now, maybe we actually want to compare, okay, whether there's a significant difference in salaries of lecturers. And of course, we have three levels, three groups that we're actually going to compare because the three major cadre exist, which is actually the tenure track, okay, and the non-tenure track. But in the non-tenure track, we got two levels. In the non-tenure track, let me just say this. In the non-tenure track, we have assistant professor. In the tenure track, we have two levels. I'm going to say that again. If we want to classify majorly, we're going to classify the cadre into two, non-tenure track and tenure track. But only that, in the tenure track, we got two levels, and the two levels are actually associate professor and professor. But in the non-tenure track, we have assistant professor. And maybe what we actually want to do is to compare salaries, okay, among, between the three levels. Of course, we have three levels: assistant professor, associate professor, and full professorship. Now, because I have three levels, I have three groups. The number of contrasts I'm actually going to construct will be 2. Okay, the numbers of contrasts you're actually going to construct depend on the numbers of groups that you want to compare. If the numbers of group in this example is 3, the numbers of contrasts is actually going to be 2. So you're going to subtract 1 from the numbers of group to actually have the number of contrasts that you're actually going to give consideration. Okay, now I now develop 2 contrasts because I got 3 groups. The first contrast, I want to compare the salary of a non-tenure track with a tenure track. If you take a look at the first contrast, it means I'm comparing just one level with 2 levels. That's a contrast. You know that? I want to see whether there's a significant difference between the salary of the non-tenure track and the tenure track. And of course, in the other contrast, I want to see within the tenure track, I actually want to see whether there's a significant difference between the salaries of the associate professor and professors. Okay, now these are the 2 contrasts that we actually want to consider. You know, these are two reasonable contrasts, because somebody can consider another possibility that what if I look at if there are any relationship between the salary of associate professor and the salary of an assistant professor. Okay, that could be another. But I want to say that if we are comparing the three using the analysis of variance and the non-hypothesis is rejected, I want to tell you that the contrast that we are actually constructing here is based on the prior information. I'm going to say that again, the prior knowledge. Because let me tell you what we mean by prior information is information you have before you collect your data. Is a probability of the state of nature before data collection. Because we know that there's going to be a significant difference in salaries of a non-tenure track and a tenure track. But the only thing we don't know is whether there's going to be a significant difference between the salary of associate professor and professor, those two cater within the tenure track. Okay, now if I want to do this in R, I need to install package, I need to load package called car. I want to tell you, when you load the package called car, the data set that we actually want to use, if you install packages called car data, you're actually going to have, access to the data set that we want to use here, which is the salaries of professors. Okay, and let me take a look at this. This is actually telling us we are looking at the effects of, because on the data set, we are actually looking at the effect of sex, okay, and rank, okay, plus the years in PhD or years of in service, than discipline, okay, on salary. When you take a look at what I have here, we got a lot of predictors. We're trying to look at the effect of them, on the salary. And you can see I put AOV. I'm not dealing with linear regression right now. I'm actually dealing with the analysis of variance, where, I have the sex, the rank, the GSNs, which means here I'm also considering the effect of some concomitant variable. So this is more or less like an analysis of covariance, because when you take a look at what I have here, what we allowed as predictor in analysis of variance should be categorical. You know that? Situation where predictor is no longer categorical, if you are also considering a quantitative predictor, then it means you are also incorporating covariate, and that now makes that to be analysis of covariance. Because when you look at, I know that sex ranks are categorical, but the years since PhD, the years in service, they are not categorical, they are quantitative, but they are the covariate, because we believe they could have effect on salary. And then another categorical variable here is discipline, because we want to see whether professor from College of Arts, maybe is going to earn more money than professor from College of Education. Okay, that is why we're trying to look at the effect. What is the role discipline also play? Okay, so at the end of the day, this is what we have. And if you take a look at what we have, rank is significant because we're interested in rank. Our contrast was actually built around rank, right? And the reason why we want to proceed for further analysis is because we realize that the rank was significant. Look at that. Rank was significant. Okay. And if rank was significant, okay, of course, we needed to construct a contrast or to be able to do what I call further investigation. Okay, so it is not only rank that is significant, the years since PhD is significant, years in service is significant, and discipline is significant as well. So what you know what he's telling us, right? So discipline play a role. Okay, the discipline of a professor actually play a role in the salary based on what I'm presenting right now. And not only that, years in service play a role in salary. And not only that, the years since PhD also play a role. Okay, a rank play a role, a significant role, not just a role, they all play significant role, except the sex. There's no significant difference in the levels of gender, okay, of professors in terms of their salary, and that is expected. You get what I mean, right? There shouldn't be any significant difference. Okay, but you know what? Based on this result that we have, we wanted to do further analysis. We can see that the rank of a professor is significant, and if you take a look at the degree of freedom for rank here is 2, right? If the degree of freedom for rank is 2, it means in this analysis, we've considered 3 levels of the cadre: the assistant professor, associate professor, and professor. And that is why you have the degree of freedom to be 2. And right now, the p-value is less than 0.05. Of course, we are rejecting the non-hypothesis that said the average salary of the workers in the cadre is the same. So it is they are not the same. If they are not the same, then we actually want to proceed to further analysis. We want to actually construct contrast. Now, there's something I did not tell you on Friday, but I'm going to tell you today. We got a strategy for constructing contrast. Okay, where we actually need to set up what I call a contrast weight. Okay, situation where a particular level has 0, then it means we're not interested in that level. Okay, that was why I said we use 0 for group excluded from a contrast. And then where we use negative, that's a baseline group. And where we use positive, that's a treatment group. Because we always compare the treatment group with a baseline group. Now I've given you the meaning, like you got, in contrast, we got different kind of sign that we can have, different combination of signs. We could have 0, we could have negative, we could have positive. But we're trying to tell you right now what 0 represents. When a particular level has a contrast of 0, then it means we're not interested in that. They want to have a contrast, weight of negative actually means we're referring to that as a baseline group. And they want to have a positive, that's a treatment group. And you know what? When I sum the contrast weight together, they must be equal to 0. Okay, now if that is taken, based on based on the result of that analysis, we realized that the rank was significant, which indicates there's a significant difference in the levels, in the cadre of the professors that we actually considered. And we were constructing 2 contrasts because we got 3 levels. And in the first contrast, okay, we actually, if you take a look at what I showed you before when I started, in the first contrast, we actually want to compare the non-tenure track, the non-tenure position with the tenure position. That is the first one. And the second one, we actually want to compare within the tenure cadre, we actually want to compare the associate professor with the professor. Now, that is what I explained here, okay? Now, I wanted to take a look at what I put here. If you look at contrast 1, you guys, you're actually going to notice that the one I use on Friday is different from what I'm using now. It's the same. Let me remind you what I used on Friday for a question like this. On Friday, I'm going to say contrast 1 under the associate prof and the prof. I'm going to say 1/2, 1/2, right? And I'm going to say under the assistant professor, I'm going to say -1, right? It's the same. I can decide to use fraction. I can decide to use a whole number. I'm going to say that again. On Friday, when I solve a problem that looked like this, I was using fraction as a weight. Okay, where I'm going to say for associate professor and prof, I'm going to say half 1/2, 1/2. And for the assistant professor, -1. But today I'm using whole numbers. Whether you are using whole numbers or you are using a fraction, is the same. Okay. Now, if you look at the contrast 1, of course, when you see an associate professor negative, then that's going to be a baseline. It means the assistant professor is a baseline. Of course, an assistant professor should be a baseline in lecturing cadre. Okay, so that's why I'm putting negative on that. Okay, and the sum of the contrast have to be equal to 0. When you look at the second contrast, I'm comparing whether there's a significant difference between the salaries of the associate professor and professor. Of course, the one that I'm actually going to assign negative is going to be a lower cadre. A lower cadre will serve as a baseline group. And that really makes sense. So when you are assigning your contrast weight, of course, you need background information. We don't just assign contrast weight. The background information is that, okay, I knew that associate professor is lower than the professor in when you are looking at the cadre. And that was why negative was assigned to the associate professor, because it's in the lower cadre. It's actually going to act as a baseline group. Now, this is my contrast weight. And I also told you something on Saturday about orthogonality. Orthogonality, they have to be orthogonal. What do I mean by that? When you look at the associate assistant professor, -2 times 0, that would be 0, right? 1 times -1, that would be -1, right? 1 times 1 is 1. When you add all of that together, it should give you 0. That is orthogonality. The contrasts have to be orthogonal. Okay. Now, the next thing that you're actually going to do now we are now in I'm going to use our software now. Okay. We're going to use our software now. Okay. In the our software, I'm going to write contrast 1, contrast 2, then I'm going to put the weight. Where is it coming from? -2, 1, 1 is 0, -1, 1. They are actually coming from here. If you want to use fraction, you can use fraction. There's no problem. Okay. Okay. And after that, then we tell how we want to tell out, want to give our information now. Okay, to assign this contrast to the variable rank. The data set that I'm using is saved with df. Okay, the data set I'm using is saved with df. Okay, and part of the variable in the data set is rank. Okay, then if you take a look at this code, contrast in parentheses, df $rank. What does that mean? I'm trying to inform R that you need to assign contrast to a variable called rank in my data set. Okay, and that's going to be C by contrast 1, contrast 2. Then I'm going to write contrast df $sign of that. This is what you're actually going to see. This is what you're going to see. How has automatically do that. How has done that. Take a look at that. Okay, you can see contrast 1, contrast 2, and you can see the cadre. The next thing, now that Haru now arrow has already assigned contrast to a predictor called rank in your data set, that the next thing you're actually going to do now, okay, is to go back and analyze again, okay, is to go back and, rerun the ANOVA again, okay, all of that again, okay, with all other variables, present. And you will be surprised, you're actually going to see a different result this time around. Let me tell you this, what you're actually going to see next is basically going to be the rank in the previous ANOVA table will be broken down into contrast, which I'm going to show you now. Can you see that now? Initially in the previous ANOVA model, okay, you only have rank, but in the new ANOVA model, it's actually going to split that into contrast 1 and contrast 2, as you can see here. Okay, do you see that now? That is now being included in the analysis. Take a look at that. Now, if we now want to take a decision now, it's very, very simple to take decision. Okay, you look at the p-value associated with the rank contrast 1. Okay, and you look at the p-value associated with the rank contrast 2. Then you actually see that the two contrasts that we run, they are significant, which means there's a significant difference between the salaries of a non-tenure track and a tenure track. And not only that, within the tenure track, there is a statistically significant difference between the salaries of associate professor and professors. And that is the reason why every lecturer wants to attain full professorship. Okay, so that is the way this is going. So if you have, do you know what I've just walked you today? What I've just walked you through today, I've just walked you through what I call analysis of covariance with contrast. That is what I've done. Why do I call it analysis of covariance? Because the predictor variables that I have, they are not only categorical, I also have other predictor variables that are quantitative, that I actually refer to them as covariates. Okay, the example of such is actually when you talk about the years since PhD, years in service. Those are the two quantitative predictor variables, which I'm actually going to call covariates. And we have 3 categorical predictors. We have the sex, rank, and discipline. Do you know that you can try to, if you can try to do a lot with this data set, you can try to do one-way analysis of variance only. If you want to do one-way analysis with this data set, you can do a lot. Let me start by saying you can do one-way analysis of variance where you are only looking at one categorical predictor on salary. And what is that categorical predictor? Rank. You can also do two-way analysis of variance. In the two-way analysis of variance, you can consider 2 categorical predictors from this data set. You can consider rank and sex. That is two-way ANOVA. You can look at the results. Okay. Now, I said you can consider one-way analysis of variance where you are only using the effect of rank on salary, and two-way analysis of variance where you are looking at the effect of rank and gender on salary. Do you know you can also you can also conduct what I call one-way analysis of covariance, where you are looking at the effect of rank on salary, then incorporating other quantitative predictors like years since PhD, and years in service. You can also consider three-way analysis of variance. The three-way analysis of variance here is when I look at the effect of rank, effect of gender, and effect of discipline, because I know discipline is also categorical. That would be three-way analysis of variance. But I want to tell you, everything in general is actually three-way analysis of covariance. This is three-way analysis of covariance because apart from the categorical predictors, we also have some quantitative predictor that we believe may have significant effect on the response. And based on the three-way analysis of covariance, we constructed a contrast, and the contrast that we constructed is basically on rank alone. We are interested in rank alone. Okay, so looking at the rank alone, and of course, you can see we are able to take our decision because they are actually significant. And of course, I said, and ANOVA revealed that there was a significant effect of professor rank on their salaries. That was the what we got before in the previous ANOVA table. And why controlling for their sex? The numbers of years since they completed their PhD, controlling for them is like adjusting for them. Okay, it's like incorporating covariates. I told you the other time, if a covariate is a variable that has significant or a variable that can influence a response is missing in a model, that will undermine the performance of that model. Okay, and that was why I said further investigation of the impact of professors' rank on their salaries using planned contrast reveal that being faculty, which is associate of full professor, was associated with a significant increase in salary compared to being an assistant professor. And that is the reason why every assistant professor will be dreaming to actually attain to be in that cadre. Okay, so, and that once being faculty, being a full professor instead of an associate professor was associated with a further increase. Okay, so take a look at that. We're interpreting the p-value that we have right now. I want to tell you the article that I gave you today will simplify everything that we have been doing. You don't need to go, for those of you, that are working on projects. Okay, I think I quickly want to say this. If you propose maybe a particular topic before, and you are not able to see data set, because I know at times it may be very difficult to get data set, you could decide to change your topic. But when you change your topic, it will not affect your score for particle 1. And for those of you who have reached out to me, I'm going to have an office hour tomorrow. If you want to discuss with me something about your practical, I'm actually going to be on ground. Like, although I'm going to attend that through the Zoom, I'm going to use the same class. I want to say that with what we have now, let me tell you this. I want to give you one secret now. Do you know that the data set that I use today, okay, you can decide to use this data set for your project, only that you can do it in a different way. There's a lot of variables in this data set. I actually consider three-way analysis of covariance today. You can decide to do something else. So there's, with now that we are now advancing on topics that we have been doing, I want to say you now have a lot of options, okay, to choose from as far as your project is concerned. Okay, so this is analysis, or this is how contrast is actually being constructed, and you can actually look for you can look at the textbook, you search, and of course, for you to be able to want to do more example on contrast. But let me tell you this. The way I understand my statistics, I like relating to real life practical situation. Even though in Africa, where it was kind of difficult to do practicals because of lack of funding, I still make sure that whatever I learn mathematically or statistically, every notations, every symbol, every equation, every model, I should be able to relate them to real life practical situation. I want to tell you my experience in teaching statistics, mathematics in Africa, Europe, and the United States. I realized that students have difficulty with mathematically related subject because of the fact that they don't familiar themselves with notations, symbols. What is the meaning of these notations in real life? I want to see it. When you tell me sigma, mu, this, what is the essence in real life? When you understand the meaning in real life, then you will appreciate what you are doing. Otherwise, somebody will be learning abstractly. I'm sorry, I don't like learning abstractly. I actually want to apply. Because the essence of learning is just for you to acquire knowledge that will make you to be able to withstand problem when you go back to the larger society. And that is the reason why you should be able to ask yourself, what did I get from today's lecture? What is the takeaway? What is the takeaway in terms of real life practical situation? Not just looking at symbols for looking sake. So I'm actually going to advise everyone to make sure you relate. What is the meaning of this to real life? I remember I attended one high school, and one of the students was asking me, why am I doing this? What is the meaning of x plus y equal to 50? It doesn't make sense. That was what the person was saying. And I sat down. I said, you know why? This x, be assuming that this x is the price of cookies. And she said, oh, I know cookies. Okay. When you start to relate, you will surely understand when you relate. So what I'm going to encourage every one of us, notations, equations, symbols, try to understand, like figure out what is the meaning in real life practical situation. And that will make you to appreciate what you are learning. There's actually going to our meeting on Friday.